All right, ladies and gentlemen, we're going to start off with Chapter 11.7, Systems of Inequalities. So when you take a look, we're going to graph a single inequality, okay? And then we're going to graph a system of inequalities. Now, the nice thing is we've done this in Algebra 1. We did this in Algebra 2. We did a little bit of this in Geom. And now this is the fourth time. Now, the thing is, though, when we're doing this, we're not just graphing lines. We're going to graph some parabolas, some circles, and some lines, okay? So we are going to do some nonlinear stuff as well. So let's go ahead and get started. Example 1, I've got x squared plus y squared is less than 9. Okay, so we should know what this is a graph of. We did this in chapter 1.5. Okay, do you guys remember what that is a graph of? X squared plus y squared is less than 9. Probably a...
Parabola.
Nope, that was a joke. Gotcha. It's a circle. And that's not a parabola, it's a circle. Okay, so back in the day in chapter 1.5, we talked about circles was x squared plus y squared equals r squared. Okay, technically we even talked about if the center is not at 0, 0 is x minus h quantity squared plus y minus k quantity squared equals r squared, but don't worry about that. So my center here is going to be at 0, 0. Okay, so 0, 0. And then r squared, for you pirates, is 9. Well, I want to solve for r, so make sure you square root that thing. Okay? So the square root of 9 now is technically plus or minus 3. But r is a distance from the center to the outside of the circle, and distances are always positive, so I'm going to omit or get rid of the negative one. Okay? So we get a radius of 3. So from your center, count up, down, left, and right 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 8, 3. And now we have to decide, do I make this a solid or dotted circle? So for my notes, I'm going to go ahead and write if it's less than or greater than, then we should know this is not inclusive. It's a dotted or dashed line, circle, parabola, or what have you. And then if it's a less than or equal to, greater than or equal to, it means it's inclusive. And then that is a solid line, circle, parabola, or what have you. Okay? So we end up with less than, so we know this is a dotted circle. So go around the circle and make a nice, pretty dotted circle. Don't make a rhombus or four-sided shape. Look at that. That's a pretty circle, isn't it? Yeah, pretty good. Everybody in class is amazed by Mr. Gotch's circles. Now, what we have to do is decide, is this circle shaded on the inside or is it shaded on the outside? Okay, so we need to test this thing. So what I recommend is just take the point 0, 0. Okay, that's always a nice one to plug in. We all agree that this is inside the circle. Okay, so I'm going to go ahead and test it. So I'm going to plug in 0, 0 here and here. So 0. Let me use a different marker. This one's kind of not showing up very well. There, that's nicer. So I'm going to do 0 squared plus 0 squared, and is that less than 9? And again, look at your alligator. Would you rather eat 0 people or 9 people? And the alligator's eating 9, which is what he's supposed to be doing. So that is a true statement. So my shading would be where that region was. In this case, inside of the circle. So that's where my shading goes. Okay? Now, understand that if you picked a point, maybe this guy right here, you pick any point you want. Let's say I pick this point over 10 up 10. If I pick 10, 10, I take that and square it. 10 squared plus 10 squared, is that less than 9? Well, 10 squared is 100. 100 plus 100 is 200. It's 200 less than 9. And you would say, no way. Okay, put a slash through that. That doesn't make sense. Okay, so if you pick a point that's not correct, then you shade in the opposite region. So if you pick it on the outside, and it's not right, then shade on the inside. If you shade on the inside and it's right, well, that's the region you should be shading in. Okay? So pick a point to test, and if it works, that's where you shade. If it doesn't work, shade the opposite region. Okay? All right, do you guys have any questions with 1? Are we okay with that? Okay? So this is the example of Mr. Gotch's circles here. Mr. Gotch has 1 skill in his, look at that pretty circle I made there. Pretty good circles, yeah? I'm making big circles on the whiteboard, impressing everybody in class right now. You want me to make another one? All right, here we go. Well, that circle, that's kind of ovally.
I think the other one's better.
The other one's better?
Yeah.
That's still not bad. Let's do it one more time here.
Beautiful.
Beautiful? Oh, man. I'm nervous. All right, let's go. Let's do the next one. I got example 2. Talk to me the next day you see me. I can draw you circles, guys, that are online. It's my 1 skill in life. All right, let's do the next one. Now I have a system of inequalities. So now I have y is greater than or equal to 2x minus 4. All right. Do we know what this is a graph of? People online, what is this thing a graph of? What do you got? Amshel, Juan, Natalie, John, what do you got?
It is a line.
Yes, sir. It's a line. Very good. Okay. I was a little nervous, but nice job. This is again in y equals mx plus b. B is -4, and m is 2, or think 2 over 1. Now, when we're graphing this thing, I'm always thinking x, y axis, put a little hump here. Sometimes you guys get the b mixed up. Okay, put a little hump on the y-axis, and there's your b. So we go put our pencil on the b. 1, 2, 3, 4. So we put our pencil on the b. It's not hard, you see. Man, we're having fun. Now it's time for rise over run, and then we go, we will graph you. We will graph you. So we're going to go up 2 over 1. That's our slope. We go up 2 over 1, up 2 over 1. Man, that's fun. Okay. So there's my positive 2 over 1 slope. Then we have to decide solid or dotted if it's greater than or equal to. Solid. It's equal to, so it's inclusive. Straight edges are great if you're doing this by hand. Okay. And now we can do one of 2 things. We can do our testing. So we can choose 0, 0 and test. Okay, and plug in 0 there and 0 there and see. Or what I always remember with lines, if I have greater than or equal to, I shade above the line. And if I have less than or equal to, I shade below the line. Okay? So always remember below has an L in it, which kind of looks like a less than sign. And below has an L in it, just like less than starts with an L. Okay? Other thing I remember is I always, when I'm introducing this for the first time to my freshmen, is I think of the y-axis as a totem pole. Do you guys know what a totem pole is? Right? And the totem pole has hierarchy of the most important person in the tribe is on the top of the pole. So if I'm above you, I'm greater than you. And if I'm below you, I'm less than you. Okay, so I find the totem pole, if it's greater than, then I shade up the y-axis above that line. If I'm less than you, then I shade below the y-axis, going down the totem pole, which is below the line. Okay, so all my shading is above. And again, you can do 0, 0. If I do my testing, if I do 0, is greater than or equal to 2 times 0 minus 4. I get 0 is greater than or equal to negative 4. And would you rather have $0 or would you rather owe me $4? So I would rather have $0, right? But after tonight, Mr. Gotsch is going to be a billionaire because the lottery pick is tonight, right? Hopefully you 18-year-olds have your lottery picks, right? No? Mega Millions tonight? Oh, man. All right, do you guys have any questions? So far, so good? All right, we take a look at the next one. I've got x plus y is greater than 2. We should also know that this is a line. And does anybody know what form this is in? Because this is not standard. This is standard. This is not slope-intercept form. This is standard form. I just gave it away. And does anybody know what standard form is good for? What is standard form good for? It's good for nothing. Yes, it is good for, no, that's a joke. It's good for the cover-up method. Using the cover-up method to find x and y intercepts, you can plug in 0 and find the x and y intercepts and graph it that way. I don't like doing that. I'd rather just subtract the x over. And then we've got y is greater than negative x plus 2. Okay. One thing to remember, if you're ever solving for y and you have to divide or multiply by a negative, make sure you flip your inequality signs. Okay, you don't have to do that on this one, but be very careful. You might have to. So again, I'll say it again. Anytime you multiply or divide by a negative, you will have to flip the inequality sign. Didn't have to do it there, though. We've got a b value of 2 and a slope of negative 1 over 1. So we go up 2, 1, 2. And then we go down 1 over 1, down 1 over 1, down 1 over 1. Okay. All right, so I have greater than. So if it's greater than, solid or dotted. So you guys know it's dotted or dashed, whatever you want to call it. And then which way do we shade if it's greater than? Do we shade up the totem pole or down the totem pole? Do we go above or below? It goes above. Good job, Jillian. So this thing goes above. Okay, and we're trying to find out where the blue and the, I guess this is fuchsia, make, what does blue and fuchsia make? Brown? I don't know. What is it? Bluish, purplish? I don't know. And that's all overlapping right here. So where does the blue and the fuchsia mix? So all right there's my solution. Okay. So basically anything that I'm highlighting here is any coordinate point is going to work for either one of these systems, either one of these inequalities. Okay. So it works for both of them. So it's got to be above the blue and above the purple or fuchsia, which is right there. Okay. Halfway done. We're okay. So far, so good. All right. Here we go. People online, give me a thumb if you're online. Let's see what kind of thumbs we got here. Thumb up, thumb up, thumb up. This is, oh, double thumbs up. Watch out, Amschel. All right, all right. And then we got a lot of people with no cameras on. Hopefully you didn't check
Mr.
out.
Gotch,
Yes.
what was the slope for that one? I can't really read it.
I have negative 1 over 1.
Okay, thank you.
Sorry about that. Gotsch font is not always the nicest font that I could choose to write with. I prefer Arial font, to be honest. Gotsch font, not the best. All right, here we go. So we take a look at this one, huh? So I've got y is greater than or equal to x squared minus 4. So I'll prose this question again. This is parably a parabola. Yes, this is definitely a parabola. It's just x squared. Now we have to decide, is this thing Which way is this thing being shifted? Remember with transformations, is this going up, down, left, or right? You guys remember? You have 1 out of 25, 1 out of 4 chances to get this right if you're guessing. Is this going up, down, left, or right? It's going down. It's yelling timber. You better move. You better dance. Hashtag Kesha. This thing is going down. Now, you guys have these fancy calculators. You should be able to use these things, right? I got y equals x squared minus 4. So if you're on the quiz or test and you're like, I don't know what this thing looks like. Well, let's try to get it right on the test, okay? So again, break out this calculator and just graph y equals x squared minus 4. And if I do that, zoom 6 it, zoom standard, and I see that parabola and it's been shifted down 4 units, okay? So you can always graph these if you want. And now if I want to go second trace value and I want to plug in and get some coordinate points to plot, you know, I can do second trace value 0, I get -4. If I do 1, I got -3. If I do like 2, I get 0, and so on. So I can plot some points there. Or I can go second graph, that's my table, and then I have all these coordinate points here from my table. Okay, so you do have options, especially if you're doing my math lab and you don't remember what something looks like. Well, you can at least use your calculator. Okay. All right, so let's take a look. Let's graph this thing. So I know it's a parabola. It's being shifted down 1, 2, 3, 4. This is how we did it by hand. So that vertex was normally at 0, 0. Now it's at 0, -4. And then I always graph it the same way. I always said, hey, go over 1, and then you go up whatever one thing squared is. So over 1 up 1 squared is 1. Over 1 up 1. And then I say go over 2, and what's 2 squared? 2 squared is 4, so I go over 2 up 4. And I could go over 3 up, what's 3 squared? 3 squared is 9er, so I could, from the vertex, over 1, 2, 3, and then up 9 boxes, 4, 5, 6, 7, 8, 9. Okay, it's symmetric. Dun, 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 dun. They took your bumper off your car?
Yeah. I wasn't even like, I don't even know how. I was parked in my spot. I wasn't like over anything.
Wait, like gosh.
Crashed into it or like I'm parked in like, how there's 2 rows? I'm parked in the first row, so I just pulled up. How do you do that?
Nice.
Shut up. Well, you're in the first row? Yeah.
Sorry, Jen just got knowledge that her bumper got knocked off her car.
Yeah, if any of you guys know who did it, let me know. Security cameras?
Aye.
How do you do that though?
I do not
How
know.
fast are you going in the Carrier parking lot?
Aye. Yeah, if you guys ever hit a car in the parking lot, make sure you say something because they have cameras out there. You'll get found out. And then you'll even get a worse ticket because you're leaving the scene of an accident. So don't do that. Your driver's ed classroom instructor tells you don't do that.
At least they told you teach driver's ed.
Yeah.
I had them for driver's ed.
Yeah. All right, so this is greater than or equal to, this is a solid parabola. Okay, and then we have to test, is it shaded on the inside or outside of the parabola? Okay, so what I would do is choose 0, 0, which is on the inside. So I got 0, is that greater or equal to 0 squared minus 4? So is 0 greater or equal to -4? And I would say yes. So my shading would be where that 0, 0 is, which would be out here, or inside here. Okay, so my shading is on the inside. Okay, so far so good. All right, next, I want to solve this one for y. I'm going to subtract this x over. We should know that this is a line. So I've got y is greater or equal to -x plus 2. So again, we know our B value is 2 and our M is negative 1 over 1. So we go up 2, 1, 2. And then my slope is what? Negato 1. Is that right? Down 1 over 1, down 1 over 1. 2 años en la escuela de secundaria, see? Or did I say that all wrong? All right, it is greater than or equal to, that is a solid line. Nobody else is in German class? Come on. German? I know. Spanish. Nobody else is in Spanish?
I'm Spanish.
See? 2 años en la secundaria? En la escuela de secundaria? See? 2 years.
Oh, that have a
High school math? Me. Or high school español? 2 años en la escuela de secundaria. El queso is mayor y verde.
I got that.
The cheese is old and moldy. All right, it is greater than or equal to. Greater than, shaded up. So I'm above this guy right here. It's getting goofy in here. So my final answer has got to be above this fuchsia one, but inside of the parabola. So that's all in here. So any point that I'm shading is a solution to this system. So that's our little shaded in area, shaded in region, okay? And it's inclusive on this part of the parabola and this line here as well. So it's got to be above and on that fuchsia line and inside and on the parabola, okay? All right, let's finish up example 4 real quick. Any questions on 1, 2, or 3? Let me know. All right, so this is, again, getting us to where we're going to be doing on the next chapter, which is applications of inequalities. It's called linear programming, okay? So they're going to give us some information, and we're going to have to graph it and find the corner points. And then eventually we're going to take those corner points and plug it into a profit function or a cost function. So that's where the applications come in. So maybe you're going to be a farmer, or maybe you're going to be a manufacturer and you want to decide what's going to give you the most profit or minimize your cost. This is some of the things that they might do. So we have 1, 2, 3, 4 inequalities, okay? I like to do these two first because this is going to put me in a very certain quadrant, okay? So x is greater than or equal to 0 and y is greater than or equal to 0 is basically saying the x's and y's are going to be positive. So what quadrant are x's and y's positive, guys? Quadrant. So where's x and y positive? Quadrant 1. Roman numeral 1 right there. Okay, so x is greater than or equal to 0 is a vertical line right here on the y-axis. If x is greater than or equal to 0, that one is actually shaded to the right. And then y is greater than or equal to 0 is the x-axis. It's a horizontal line right there. And that one is shaded above. So that puts me here. So it's to the right and above. That puts me into quadrant 1 right here. Okay? So everything I'm looking at is only in Q1. Well, now I'm going to graph these other inequalities, and we're going to find out what shape I get. So I'm going to go ahead and subtract that x over, and I get y is less than or equal to negative x plus 3. So I put my pencil on the b. My b is 3, and my slope is, again, negative 1 over 1. So I go up 1, 2, 3, down 1 over 1, down 1 over 1, down 1 over 1. Usually, if I'm graphing in just the one quadrant, I will do my slope all the way to the other x-axis. That way I get a nice accurate graph, especially when I'm trying to find corner points. Okay. Now that one is less than, so right now I'd be in this little triangle now. Okay. So really that little right triangle is where my shading is. But I've got one more inequality I got to do. I got this one. I've got 2x plus y is less or equal to 4. I'm going to subtract over, and I get y is less than or equal to negative 2x plus 4. So my b value is 4, and my slope is negative 2 over 1. So I go up to 4. Now I go down 2, 1, 2 over 1. Down 1, 2 over 1. Now I look at that line. That is, again, a solid line. And that one is shaded below as well. So my final answer is in this quadrant. And it's below the fuchsia line in this mauve-colored line. Okay? Now, if I zoom in a touch, let me zoom in a touch to adjust the graph. Okay, you can kind of tell that there is 4 sides to this shape. What do you guys call a 4-sided shape? A what? That's 3 or more. What's a 4? Everybody forgets this one. Everybody knows a 3-sided shape is a triangle. What do you call a 4-sided shape? No, that is a 4-sided shape, but that's a very specific one. Everybody, rhombus is a very specific one. Anybody online know what a 4-sided shape is called?
Quadrilateral?
Yes, the old quadrilateral. Good job, Jack. Okay. Everybody remembers the square and the rectangle and the parallelogram. The generic 4-sided shape is just a quadrilateral. So we have 4 sides, which means we have 4 corner points. We have this guy right here at 0, 0. We have this guy right here, which is over 1, 2. So that's 2, 0, not 0, 2. We have this guy up 1, 2, 3. So that's 0, 3. And then the last one is over 1, up 2. That is 1, 2. Now sometimes those two intersect at like a decimal, and that's where you might use your calculator to graph this guy and find the intersection. Go second trace intersect and find it that way, or you could do substitution or elimination and solve it. But most of the time you're going to be able to find that corner point pretty easily just on your graph paper. But if you're not using graph paper, oh man. Okay. All right, ladies and gentlemen, that is it. I hope we're okay with goals number 1 and 2, graphing inequality and graphing a system of inequalities. And that is all I have for today.